In these sections, we talk about the elementary functions, and then we review the basic about graphs. The compositions operation of two functions is we use one of them and plug it into the other ones. And the notation is this is f of x, in this case, plug into g, and in this case, g of x is plugged into f. So for this one, first one, plugging f into g, f is sine of x, so plug that into g, I get square of sine of x. But next one, we're plugging g, which is x squared, into f, sine of x squared. And if I use the operation compositions and add, subtract, multiply, divide, if I use those operations and use these basic formulas as building blocks, and what are the basic formulas? Polynomials, trig functions, the ones that you see on the calculators, those are basic formulas. We take those, we add, subtract, multiply, and then take composition into layers, and these class of functions we create are called elementary formulas. For examples, here are three functions, and here it asks us to expand. So we can do this part by part. H times f, we can multiply that, and the compositions, and I can put them together into this elementary formula in the expanded form. These. Conversely, I can deconstruct our elementary formula. For instance, if I want to deconstruct these formulas into compositions and basic formulas, then we can do it this way. I let f of x be the polynomials. This is going to plug into sine of x to get sine of 9 plus x squared. Then I cube that and multiply by 4, then plus 5. This is how the formulas are layered by composition and add subtractions. It's important that we can do this, okay, because later on, a lot of properties of functions I can deduce from that. Pictures. Y of x is a basic graphs, and these are basic pictures that you will see in general. Here's x, and then a generic form is x f of x. First degree graph. How do you graph first degree? You plot the intercepts, then you connect the lines, straight line. How do I graph second degree? You plot the vertex first, and after you plot the vertex, you find another point, plot another point. Then the third point is always flip across a vertex. You can deduce that. You don't need to. You can easily find what that point is. For example, to graph this, you graph the vertex, and then I graph 0, 8. Then the other point must be here. -2, 8. Then you connect that, and those 3 points makes the parabola. You find the x-intercept by solving them. This is how you're supposed to graph parabola, which is important. And these are some basic graphs we use quite often. The two other operation, absolute value operation. If I take absolute value of a graph, it flips all the negative parts upward. So here's what it does in this one. And then the other things that we can make functions out of piecewise or multi-rule functions. So this formula actually comes in 3 parts. For x bigger than 0, for x exactly 0, for x less than 0, they have different rules. If I plot these, I get these as graphs. Okay, and that's a basic review on graphs and formulas. Bye-bye.